Hello out there in internet land. This is Chris Compton, CEO, HVACR, edu.net. Interesting fact, the biggest stumbling block in the HVACR technical workforce is electrical knowledge. This discovery has been made by compiling the results of national certification exams as well as HVACR, edu.net's TCA process where we assess. So far over the last 20 years, we've probably assessed tens of thousands of technicians in the field. And consistently, electrical is one of the biggest holes in the knowledge base. The irony of this fact is that 80% or more of all the work done by technicians in the field is electrical in nature. Almost everything that we work on is driven and controlled by electricity. So it would seem to make sense that you need to know about electrical. DC is considered natural voltage because it's found in nature. Lightning strike, zap, negative to positive, static electricity. DC is created by chemical reactions, dry and wet batteries. Here's a dry battery down here, flashlight battery, AA. Here's a wet battery in your car. DC is created by photovoltaic solar energy panels. Here's some panels down here with the sun shining away. DC is created by mechanical generation. Here's a motor generator set, another way to create DC. And then digital DC is created by electronic manipulation using alternating current, AC, as the source. Inverters and converters, all right? DC electron flow, if you're looking at your meter, your VOM, your voltmeter, is continuous from negative to positive. I think we've established that already. And the symbol that you'll see on your VOM that represents a straight DCV, direct current voltage signal, is this line right here, straight line. If you're looking at your voltmeter, that's what you'll see for a straight DC. Digital DC voltage is a pulsing signal because it's created from alternating current. In other words, alternating current spikes 120 times a second, 60 times a second it spikes positive, 60 times a second it spikes negative. And what they do with an inverter or a converter to create direct current is they take those spikes and create a digital DC, which is represented on your VOM right here in the dashed line, okay? Voltage equals potential difference equals electrical pressure, also known as, or AKA, electromotive force. Voltage is pressure created by the strength of the positive and negative magnetic poles that are presented at the opposite ends of a conductor, all right? You see down here, I've got a negative, I've got a positive. The negative is pushing or repelling, the positive is attracting or pulling. And once again, we're talking about that free electron in the outer orbit of the copper atom. And all of them are going from the negative end to the positive end of the conductor. And the potential difference between the negative magnetic force and the positive magnetic force is voltage. This says it all. Water pressure is the electrical pressure measured in volts. So the comparison of water pressure and voltage is a very good comparison. In other words, somewhere up this pipeline here on this water, there is a source of pressure, whether it be a pump that's pushing water into the hose or the pipeline, or whether it be a gravity flow, whatever it is, there is pressure there making the water flow through the hose, through the pipeline. Same thing is with electrical. Electrical voltage is the pressure that causes electrons to flow, all right? That's the great analogy of electrical system to a water system. Voltage is the pressure. Magnetic lines of flux. So if voltage is the pressure that causes electron flow and voltage is created by the push of the negative or the repelling of the negative and the attraction of the pulling of the positive, that's all about magnetic energy. All right, so you need to know something about magnetic energy. And what you need to know is about the magnetic lines of flux. If you've ever played with magnets, you realize that there's an invisible force that is caused by the magnet and extends outside the magnet's physical size. As you can see here in the image, we have these lines of force coming out of the north end of the magnet, as they say, going back into the south end of the magnet. So there's this force field around it. To further understand electron flow and the basic concept of our electrical technology, this is how free electrons are forced to move through a copper conductor. Opposites attract, likes repel. Remember your experience with magnets. We've all played with them. Presenting a strong positive force at one end of the conductor and a strong negative force at the other end of the conductor actually moves these electrons, these free electrons, towards the positive force. All right? The negative repels, the positive attracts. The opposing forces used to move electrons, negative and positive, is called potential difference, which is also known as voltage. The stronger the difference between the positive and negative magnetic forces, the stronger, the higher the voltage. And here's my little sign here, potential difference. I'm measuring from negative to positive. And what that would be measuring with a voltmeter.